Hey guys, this is the last lesson of Unit 7, and in this unit we're going to solve right triangles. Actually, what we're going to do is we're going to kind of start from the beginning with what we know about right triangles and go through just deciding what to do in each situation. And then our last example is where we're going to do what we call solving a right triangle, which is finding all of the sides and all of the missing angles in a right triangle. So without further ado, we're going to go through two situations where you're asked to find an angle. So go ahead and you'll definitely want to write all this stuff down. So if you have two angles of a right triangle, and at first glance, it kind of only looks like you have one angle, you kind of only notice the 35 degrees, but then you have to remember that the right angle down here is 90 degrees. So we actually do have two angles given to us, and we're asked to find the third. If that's the case, you could have done this like way back at the beginning of the school year. You don't have to do anything fancy here. You don't have to use any trigonometry. You just have to remember to use that triangle sum theorem. I'm just going to abbreviate it like that. In other words, your three angles need to add up to 180 degrees. So if you just want to punch it into the calculator, great. If you want to show your work a little bit better, you could do 90 degrees plus 35 degrees plus something is equal to 180. That's probably really the best way to do it, but I'm not going to be super fussy. 90 and 35 is 125. Ultimately, what you're doing is 180 take away 125, which is 55. So x is 55 degrees. So I really just wanted to remind you of that. If you already have two angles, it's a pretty simple one to figure out what that missing angle is. Okay. Now, in this situation, we only have one angle given to us. So we have the 90-degree angle, and that's it. We don't know what x is. We don't know what that lower right-hand corner is. So we can't just subtract from 180. So that's the point where the trigonometry stuff comes in handy. So I'm just going to write trig, or in other words, SOHCAHTOA. All right, so let's just go ahead and do this one. We only have the one angle, but we do have two sides. So we're able to label those two sides as opposite and adjacent. In this case, the hypotenuse is over here, but we don't really care about it because they didn't give us a number over there. So tangent is what we're going to want to use because we have opposite and adjacent. So I'm just going to set it up as tangent of x degrees is equal to opposite 7 over adjacent 5. Okay? And then anytime you're trying to get something out of a sine, cosine, or tangent, that x is stuck on the inside, division doesn't work. What we have to do is take the inverse tangent of both sides. There we go. And then this is what we need to punch into a calculator. I'm going to pull up the Desmos calculator and just give you a reminder about how to use that one, in case you forgot for some reason. First thing you want to do is hit that wrench button, change your calculator into degrees, then go over here. There's a keypad in the lower left-hand corner, hit that, and then functions, inverse tangent, and I forgot what I'm typing in, 7 over 5. 7, oops, I got out of there now. 7 divided by 5. I need to delete. All right, so 54.46. Typically when we're solving for angles, we just round to the nearest degree. So just to 54. The 0.4 is closer to 54 than it is to 55. So 54 is what we'll write down. And that one would be done. All right, now moving on to sides, and we've done a ton of this, so if this seems like review or like I'm sounding like a broken record, that's fine. I'm just trying to kind of consolidate all of our stuff into one spot. So if you have two sides of a right triangle, then you can't really use trigonometry because you don't have any angles. So your option then is a squared plus b squared equals c squared. Okay, and I am not even going to do this whole problem. I'm just going to remind you that the hypotenuse is always C, and then A and B go on your legs. and then each of those fill into your equation. Again, I'm not going to do the whole thing because you've seen enough of those at this point. All right. Now, trigonometry comes into play if you only have one side. So we have 4. That's our one and only side. We don't have the hypotenuse. We don't have the adjacent side. So at that point, our only tool that we could use is trigonometry. And we do have an angle, so we are able to label as opposite and hypotenuse and go from there. So if you only have one side, that's where trigonometry, trig for short, SOHCAHTOA, is going to be the most useful thing. Again, I'm not gonna do this whole one. I'll just set it up. So sine of 23 is equal to our opposite side 4 over our hypotenuse x, and we'd solve from there. All right, now this is where we get to something sort of new here. So it says solve the right triangle, and you'll definitely want to write this one down. We can even call it example 1. It's our only example. If someone asks you to solve a right triangle, they are really asking you to find all missing sides and angles. And in a right triangle, or in any triangle, there are 3 sides and there are 3 angles. So we really need to come up with 6 things. Right now in this example that's given to us, we only have 3 of those 6 things. We have our 90-degree angle, and then we have 2 of our sides. Our task is to find everything else. Now, a lot of times it really doesn't matter where you start. I think when you first see this, I think your first instinct is to solve for the hypotenuse, and that's fine. But we could find one of the missing angles first too. It doesn't really matter. What I always tell people is to fill in some variables so you can keep your work straight. So I'm going to put an x over here, a y degrees here, and a z degrees here. And when you do your own, you might label them different, and that's totally fine. There's no rhyme or reason to why I did that. I just need something to fill in those missing areas so that we can keep our work straight. So yeah, like I said, I think our first instinct is to probably find x, and we're going to do that using the Pythagorean theorem. We have 2 sides, so we can find the third side doing that. So I'm going to do 4 squared plus 7 squared equals x squared. 16 plus 49 equals x squared. 65 equals x squared. And then the last step would be to take the square root of 65. And I'm going to hop over to Desmos again. Get a new line. Square root of 65 is about 8.06. And then I'm going to fill that into the triangle. Okay, so at that point we have all 3 of our sides. We're done with that. We have 4, 7, 8.06. C should be the longest side, so that's looking really good. Okay, now we have to find one of our angles. It doesn't matter which one we choose. I'll probably choose Y, since that's the next letter in the alphabet, I guess. And then I would probably use the 2 numbers that they gave us. So 7 is on the opposite side. And we could use the hypotenuse, but I'd rather not, just in case we made a mistake there. We don't want to compound our mistake. So we have the opposite side and the adjacent side given to us. So we're going to use tangent to find y. So tangent of y is equal to 7 over 4. And these ones are really quite simple once you get them set up. It's not a ton that you need to do. Take the inverse of both sides, and that will give us y. So I'm going to go back to Desmos, inverse tangent of 7/4. So functions inverse tangent 7 divided by 4. And again, we'll just go to the nearest whole number. We'll just go to 60 degrees. All right, now the good news is we don't really have to use trigonometry again. We could if we wanted to, just to check our work, and maybe I'll do that on this one really quick. If we were going to use trigonometry to find angle Z, then 4 would have been the opposite side, and 7 would have been the adjacent side. So we would have really had almost the exact same setup. Tangent of, sorry, I should be using z, not y. Tangent of z is equal to 4/7. Take the inverse of both sides. I'm just going to go in here and just change these around. 4 divided by 7, and we get 29.7, so that one's going to round up to 30 degrees. Okay, now I say that we didn't have to do that, z equals 30 degrees, because once we knew that we had a 90-degree angle and a 60-degree angle, we could have just subtracted those from 180 degrees and we would have ended up with 30 degrees that way. So it's up to you. If you like the trigonometry thing, it's not that difficult. It's a nice way to check your work and make sure that everything's working out right. Or once you get the two angles, if you just want to subtract from 180 to get your final one, that's totally fine too. All right, sorry this one ran a little bit long. You are welcome to go ahead and do your 7.7 practice.